All right, welcome back. Today is November the 9th, and we are going to try to finish chapter 9 today here with the practice homework. One thing about the next quiz, I'm thinking the next quiz, I probably will set it up as a take home also, so that we can use Friday as a lecture day. I still have to figure out um, how to do it so that you can do it during the entire day at any time, and but only once you open it, you have 25 minutes. So that's what I'm going to try to do. I had to figure out how to do it, but I don't think that should be a problem. And the uh, next the makeup quiz will also be like that, and I'm planning on doing it early the week that you are off. Okay, so that you can enjoy Thanksgiving. It will be optional. You don't need to take it, and so that I don't feel that I'm making you work that way. But you will have the opportunity to get some more points there if you want to. All right. Likewise with the homework 11, I don't know if I'll be able to set it up. I want to set it up because at least you will have practice for it, and it will have to be done during the break. So that one I will also make it optional if I make it. That way I can knock off, one of your lower homeworks. But most of you are doing well in the homework, so it's all gonna be optional. Anything past the break, it will be optional, but you'll have the opportunity to make points. All right, let me let me get started here, and let me check on my online students real quick. Yeah, not a whole lot. All right. All right, let's get started. So, all right, so let's see. Why is this like that? Yes.
For the test, is it going to be just chapter 9 and 10?
9 and 10.
11?
No, 9 and 10 only.
Okay.
Yeah, so homework 9 is already up there, and homework 10 I set up this morning. So you'll have it. So those two, but chapter 9, honestly, is equivalent to 2 chapters. So that's why we actually have the material for like three chapters for the next milestone. All right. So yeah, and then chapters 11 and 12 will not be in the MIT 4, but they will be on the final. So I feel like I still need to give you some problems for that, even though you'll be on the break. Yeah, so just study a little bit and enjoy your break, and then get after Thanksgiving you study a little bit again and get ready for the exam. This class will have the exam on December the 4th. I think it's from 10:30 to 12:30, so it's a little earlier. And the 8 o'clock class will have it on December the 7th, which is a Monday. Yours is a Friday, theirs is a Monday, and there it goes from 8 to 10. So I guess they compensate them a little bit for waking up earlier, taking it later. So yeah. So I have a chat question here. We cannot see your screen or not. Yeah, because I haven't touched the button yet. Thank you. All right. Yeah. So here we go. So last time when we met, we were talking about substitution and elimination reactions, and today, hopefully, I'm gonna really teach you how to dissect these reactions. All right. Okay. So this page is perhaps the most complete page of the entire worksheet. So the way we were doing this was that I'm gonna use green for the heart on the right side. We were like doing like an investigative analysis here, and so first of all, so what do we see here? We see a. I'm gonna refresh you, and then I'll ask you more questions, and you fill in for the other ones. So right now, what I see here is a secondary alkyl halide. I notice that I have low temperature and I also have a charge. Well, this is a strong because it's charge. Strong charge nucleophile or base, and I have a polar protic solvent. No, polar aprotic. My bad. Polar aprotic solvent. All right, so that's what I see here. And so, based on this information, what can you say the type of the reaction is? All right, so first of all, knock it down to 50-50. So eliminate the E's or eliminate the S's. That way you get 50-50. So what do you think? Someone is on the chat saying SN2. Aaron, you are right. Very good. So it's an SN2. What made you think it's SN2? So please fill me in. What made you think it was SN2?
I saw polar aprotic solvent, a strong base, and then it was secondary. So that means it couldn't have been E2 or E1.
Well, yeah. So the thing that's the most important here is actually that it's strongly charged. That makes it either E2 or SN2. All right. Now the next thing that gives away this reaction is that it's low temperature, because then you say, okay, if it's low temperature, it's SN2. If it's high temperature, it'll be E2. All right, but you knocked out the ones, like E1 or SN1 are knocked out based on those assumptions. All right, so if it is SN2, notice that the publisher kind of like messed up here. This molecule could have been done chiral, but because it's not chiral from the beginning, that we have to assume it's racemic. So we just put a single bond there, and then we write CH2, CH3 with the S there. All right. It would have been cooler if they would have made like this, like that, and then we would have gone like this, you know. But no, they didn't do that. So we'll take what we're giving. So how about that? All right. All right. So let's do the next one. All right. So for the analysis, I have here what group is this? It's a methyl. All right. You can fill me in now and help me out. So we have a methyl alkyl halide with what? What else do you see? This? Yeah. This is well, we don't have a solvent here, but we do have a strong charge nucleophile or base. We don't know if it's a nucleophile yet or if it's a base. I'm just writing down what I see. And low temperature, 5 degrees, and no solvents. So, all right. So, based on that, what makes you think this reaction is SN2? Why is that?
Because it can't abstract a proton and make an alkene if there's not.
Exactly right. A methyl cannot make an alkene because it only has one carbon. So immediately you say that this gotta be SN2. All right, very good. And you just need that piece of information actually for this problem. So we made that. All right. Let's do the next one. The leaving group here is the tosyl group, and that leaving group is on a tertiary carbon. This guy is tertiary, has 3 carbon neighbors. So we say we have a tertiary alkyl halide. That is an excellent leaving group, actually, tosyl group. It's a really good leaving group. And then we have a weak neutral nucleophile or base. The temperature is low, and the solvent is polar protein because we have water. All right, the moment that you only have one solvent, one nucleophile solvent, you know what's that. Yes, sir.
I was just going to ask a question actually about the temperature.
Mm-hmm.
So I know you said that above 60 degrees is considered high. So is anything below 60 low, even if it's like sort of room temperature?
Yeah. Anything below 60, 50, 40, that's considered low. And the minuses too. Yes, ma'am. This is an SN1 reaction. Very good. Yes. It's SN1. What made you think it's SN1? What's the major feature of this reaction that made you pick it like that?
That it's just H2O, just
Yeah.
solvent.
Yeah, so it's a solvolysis. This will be solvolysis. Just one solvent. Solvolysis. And also the fact that this is tertiary, that helps you reinforce that. So yeah, SN1. Let's see. So what we'll have is a C with a CH3 here. And I have now an OH group here. All right. Very good. Let's do the next one. So what I see here is also a tertiary alkyl halide. This carbon here is tertiary, has 1, 2, 3 carbons around the carbon that holds the leaving group. It's a good leaving group. We have a good leaving group. And we have a weak again, neutral nucleophile or solvent or base, low temp, and it's polar protic. So all of that screams what?
Could I take a shot at this one?
Yes, what would it be?
I'm thinking since it has the weak base,
Mm-hmm.
yeah, the weak base, I would probably say E1.
This would be an SN1.
Okay.
Yeah. So weak base, low temperatures, benefits SN1. Actually, for you guys, I kind of messed up. I just updated the comparison table. I put it for the 8 o'clock group on Friday, and I didn't transfer it to your class. So, but I just put it this morning. So it should be in there. So this will be an SN1, and basically I was just talking about. Let's go there real quick. Important handout. So it's on also in Canvas. It'll be called, the folder is called important handouts. And so basically it's this. So for the SN1, SN2, we prefer low temperature. But if you don't have the temperature, you should also figure it out by the other conditions. All right. Sometimes the problems will not have the temperature. But yeah. So try to make sense of this table. It's in Canvas for you guys now. All right. So this is an SN1 reaction. So we will have this, right? All right, so that would be the product for that reaction. All right, we have a few left. How about the next one? What do you guys see here? Tertiary alkyl halide again. I see a strong There's a good leaving group, and I see a strong charge nucleophile or base. When you do the milestone, please do this stuff that I'm doing. So the reason I'm teaching you is to train you. So this will give you the tools to success. This temperature is high, so it's high temp. I'm just gonna put a T. And I have a polar protic solvent, this one right here. All right. Okay, so what does that look like to you? What that is gonna do? This is perhaps one of the most interesting problems. Let's think about it, okay? It's an E. We cancel the S's, so it's an E, but it's S2. It's E1. So it's an E1. I'm sorry, what am I talking? Dyslexia, please, sorry. It's an E2, all right? So, why is E2 and not E1?
The nucleophile, the base is sterically hindered and the solvent.
Yes. So we have a strong charge, nucleophile or base. This base is also bulky. So it's hindered. So this thing here is potassium dibutoxide, and it looks like that. So these are methyl groups. They are really big. So it's bulky. It's not going to be a nucleophile. So it's going to be an elimination reaction. And because it's charged, it's 2. It's not going to be a 1. See what I'm saying? So it has to be an E2. All right. So what are the products for this reaction? So your options are option number 1 here or here. Those are equivalent. So I'm going to delete one of the two. All right. I'm deleting 1. And this one, this is my option number 2. All right. So if I deprotonate here, let's call this one A and this one B. If I deprotonate on A, what product will I make? Decisive product. Very good. So it'll be like this. I'm just gonna do it. You can put the double bond here. It's fine. I'm gonna put the double bond here. Same thing. It's almost like if I withdrew this H instead. That's the one I should have kept. All right, yeah, so that gives that. And then the other one will give you, so if I deprotonate here, this will swing down like that. And we'll make this product. This is this Hoffman. So this is Zaitsev, and this is the Hoffman. All right. Which one will be the major though? Anybody? The Hoffman, because you have a bulky base. Bulkiness prefers Hoffman. So this is the major. All right. So that's what we have. Anybody wants to add something here? All right. Let's do the next one. Again, we have a case of a methyl here. And that pretty much says it all, right? Methyl RX. We have a weak, notice this, we have a weak nucleophile or base. and we have low temperature in a polar protic solvent. Seems like that looks polar protic to me. So they're using the nucleophile as the solvent, or they're making this reaction run neat. Sometimes you take one in one equivalents of your solid, and then your nucleophile will be a liquid, and you mix them up together, and the nucleophile acts as a solvent because the reaction is being run neat. All right. So you end up with this product, and this is an SN2. There's no other way for that one. All right, let's do the next one. And my online students, please feel free to participate. Check out what we have in here. The electrophile is a secondary alkyl halide. We have charges in the nucleophile or base. So we have it strong because it's charged. Nucleophile or base. We have 78 degrees, so that's high temperature. Polar protic solvent, ethanol. So what do you think we have here? This is where there is a problem here. You have a secondary alkyl halide, and that's where you had to switch between E2 or SN2. You had to decide between those two. Eliminate the ones. The SN1 and the E1s don't fit here. All right? So what is it? Yes, my man. Very good. It's E2 because of high temperature in this case. So if I give you this problem, I had to include the temperature. All right? Otherwise, it will be really hard to pick. All right. All right. What would be the two? Oh, what would be the final product? So you have this H could be taken, and then how many products would that make? One or two? Two. Which ones are those? Cis and trans. My man. Very good. There's your trans. Let me draw it better. Like that. That looks like that. So that'll be your trans plus your cis. All right, trans will be favored. This is the major. All right. Okay. Two more. And I'm going to make an extra problem here because I have one that is a little more exciting. Someone asked me earlier, oh, so that means in the eliminations, we always get two elimination products. I said, not necessarily. It depends on the case. So I'm going to give you a case where you see that. All right? But let's finish these two before I do that. Oh, let's do it right now. Let's do it right now, since we're talking about it. That way we save time. What if I give you this? So please add this up to your notes. Because this was a problem that I had to solve on my feet this morning. So I want to share it with you guys. So let's say I have this, and I'm gonna add a small strong base, sodium methoxide, in the presence of ethanol and under heat. All right. we're only gonna get one product, and here's the reason for why that. So this H here is up, and this H here is down. So those are the only two hydrogens you can grab. Which one will you grab? The one on the top or the one on the bottom? And why? And one on the top, why? Anti-periplanar. Yes, it has the anti-periplanar configuration, and that is exactly what I'm looking for. This the base grabs that, pushes the double bond right there to be formed there, and the bromine gets kicked out. Notice that in situations like this, you will only form one product. So this double bond cancels this chiral center right there. You see that? Now it's flat. But the other methyl group needs to stay up. So try to keep it up like that. All right? I mean, keep it down like that. So you only have only one product here. And this would have been an E2, where you have a secondary alkyl halide, high temperature, strong charge, nucleophile or base, and you have a polar protic solvent in ethanol. All right. So be in the lookout for these things, because those are more fun to deal with. Another thing that you have to look for is like your favorite alkene will be one that might have conjugations. So if you have already a double bond in the ring, look for conjugations. If you have to decide between two final products, let's say something like this. I don't have a problem out of the top of my head, but let's say you make this versus that. This will be the major because of conjugation. All right, does that make sense? In other words, I can pull it out. I guess I can pull it out from my head. Let's say we have this. We have a double bond here. Let's see, we have a double bond there. Hold on. Let's say I have a double bond there, and I have a bromine here. So if you add T-butoxide in the presence of sodium and T-butanol, this will be the major product. You see that? Because of conjugation. All right. All right. So let's do the next. Any questions? Any questions up to this point? So this one will be major because of conjugation. You have a double, single. Let me make that prettier. So you can see the double, single, double pattern. See that? So your options to deprotonate here were here or here, and so this one is the major one. And you have two hydrogens there. Both will be, one will be up, one will be down, so you can choose the anti-periplanar one. All right. All right, let's move on here. So the next one, let's do the next one. So what do we have here? We have a tertiary alkyl halide. We have a weak nucleophile or base. We also have low temperature, and we have a polar protic solvent in water. All right, what do we have there? SN1. Very good. What may you think is SN1? Yeah, very good, Aaron. It's SN1 because we're dealing with a weak, two things, weak nucleophile, and also it's a tertiary alkyl halide. Yeah, it's perfect condition for SN1. Also low temp. So over here, so for the SN1, see, we'll have low temperature. Okie dokie. So this is SN1, and the product will be, again, this is achiral, so we only have to worry about normal single bonds like that. Very good. And the next one, okay, the next one, this is a cool one that I liked. I'm gonna teach you something new here. Check this out. What is the alkyl halide? Tell me, what is that? What type of alkyl halide are we dealing with there? Allylic, and what else? It's allylic and primary. You see, it's 2 in 1. So it's really good. So allylic and primary, what does that tell you? Like before we even fill everything out. SN2, yeah, it's one of the most reactive ones. I'm gonna write it down here. But let's finish up the analysis. So we have low temp. Oh, let's put the temperature after the charge. We have strong, small charge, nucleophile or base, and low temp, and we have methanol there, so that's a polar protic solvent. All right. So SN1. So actually, this reaction happens to be what is called an SN2 prime. Check this one out. So this is a little different. You learn this maybe next semester or in advanced OCHEM. But why not teaching it to you right now so you can learn it? You're not going to be required to know this on the milestone, right? But just for general knowledge, you should know this, because check this out. They call this the SN2 prime because this reaction will give you the same product if you attack the carbon holding the leaving group, or if you do this. This is beautiful, like backside attack to the pi bond. The pi bond releases those electrons there, and then it kicks off that bromine like that. How super duper cool is that? And you still get the same result as if you were attacking right here and kicking off there. Same thing. Check this out. You get the double bond and the OCH3 group will be at the end. Now, how do they figure it out? So they can label the carbons. You label carbons, and you run an NMR, and you will find out that this carbon is this one that was labeled here. And then you say, oh, so that's an SN2 prime. That's how you figure out that is different. All right. So we're good here, and we have, let's see, like 15 minutes to cover this up. All right, let's do it. So for number 5, I call this page the Battle of Stalingrad. This is Russia versus Germany right here. So Zaitsev versus Hoffman, the motherland versus the fatherland. All right, let's get to it. All right. So it says, consider the reactions below, predict the products of each reaction, and indicate on the blank line whether the reaction is under Hoffman or Zaitsev rule. Circle or box the major product for the reaction, or for each reaction. All right. So all these reactions here, they fall into, let's see, these are all E2s. You see that? They're all going to be E2s because they all have charged and strong nucleophiles. So you can just say, okay, these are our E2 reactions. All right, let's do the first one. What do you see here? You have a tertiary alkyl halide, charge, strong. This is going to be a small, strong, let's call this base because we know it's not going to be nucleophile. Well, let's keep it like this, like we've been doing. Nucleophile or base, it's going to be a base in this case because it's E2. And we have polar protic solvent here. What would be the major products here? So here are your options. For Hoffman, you can pull this H, or this H here will be equivalent, so I'm going to delete one to avoid confusion. And for Zaitsev, you can pull one of these H's. All right? So if I pull this H, I will be making the Zaitsev product. It'll make that. And if I pull this guy now, that will make the Hoffman. Which one of the two is favored and why? Zaitsev. This is Hoffman. Which one is favored?
Because it's a small base.
Exactly. The Zaitsev because it's a small base. So Zaitsev wins here. Oh, motherland, they win one. Okay. All right. So they win one. So let's do the next one. We have now a bulky here. Ooh, bulky. Bulky, strong base. I'm gonna write nucleophilic just in case we've been doing it, but we know these are bases. The T-butanol is a polar protic solvent, and also I have a tertiary alkyl halide. So the products will be the same. You notice that? Same exact final product, different outcome. Here, the Hoffman is preferred, right? Because you have a bulky, strong bulky base. So that's 1 point for Germany, 1 point for Russia now. All right. The battle of Stalingrad continues. All right. So here we have the next one. Check this one out. You have a small, strong base, but you have a bulky leaving group. Woohoo! I switched the roles there. And water is polar protic, and you have heat. You're definitely gonna do an E2. Which one is it? Which one will prevail? The Zaitsev will deprotonate here, and the Hoffman will deprotonate here. Which one wins and why? Anybody? No. You know? You know? No, we can have hot for both. We can have hot for both, yeah. I guess you're not a machine anymore. You're human. So no, that's fine. This is the Hoffman will be preferred. because you have a bulky leaving group. So yeah, Hoffman